Hello and welcome to Mixture of Experts. I'm your host, Tim Hwang. Each week, we bring together a panel of researchers, product leaders, engineers, policy experts, and more to discuss, debate, and distill down the week's biggest news and trends in AI. So today on the show, 3 stories. First one, the state of the open source. What are the biggest trends in open source models and how will they shape the business of AI? Second, the future of retrieval augmented generation, or RAG. They've come so far. Where are they going to go next? And then finally, Kolmogorov-Arnold Networks, or CAN. What the hell are they? Why are all the nerds suddenly talking about it? And should we buy the hype? So today on the show, I'm ably supported by an incredible panel of experts. So first off, Marina Danilevsky, a senior research scientist at IBM. Marina, thanks for joining.
Good to be here.
Yeah. And particularly thanks to you for joining so early Pacific time. David Cox, VP AI Models and Director of the MIT IBM Watson Lab. David, thanks for joining the show.
Pleasure to be here.
And returning for the second episode, we were joking that we just make this a Kush Varshney show going forwards. He's unfortunately declined that. But Kush Varshney, IBM fellow working on issues surrounding AI governance. Kush, welcome back to the show.
Yeah, it's great to be here. And I'm the Varshney with the hair. So, yeah.
We'll use that as a little mnemonic. So. Well, great. So let's start with the first story that we want to cover today on Mixture of Experts. So I think from where I'm sitting, there has been just so much happening in the world of open source, right? So Meta, of course, released Llama 3 a few weeks back. Apple, in a very big move for them, I think, released the open ELM on device models. And then IBM just recently released its Granite family of models. And so David, I kind of want to give you a chance to kind of first plug Granite, tell us what it is and what you guys have been working on. And then I kind of want you to kind of go into, why it is that IBM decided to release Granite open source and why it thinks that doing this matters. And I think from there, I think we could talk more broadly about what's happening in open source, but I wanted to give you a shot to talk a little bit about the work that you and the team have been doing.
Sure. Yeah, happy to. We actually had 2 major open source announcements. This was a big week for us across IBM and Red Hat. The first was that we open sourced the Granite code family of models. So these are models in a variety of sizes, 3, 8, 20, and 34 billion parameters, trained on 116 programming languages. These are, state-of-the-art models, competitive with, the best in the field. And one of the areas that we really optimized for enterprise users, because ultimately IBM is interested in supporting enterprise, is that all-around capability, not just Python and code generation, which is often the focus for the academic community, but also Java and Rust and all kinds of other languages, and also things like code fixing and explaining. So there's a lot of things you can do with code models, and it's really being integrated into the software development fabric of how we do software. And software is integrated into the fabric of everything we do in society. And we wanted to release these because ultimately our position is that open wins. Communities will build around these models. People will build things that we wouldn't expect. They'll be able to extend the models, and that's super powerful. And that leads a little bit to the second announcement, which happened through Red Hat. So we have a technology that we've developed for doing alignment of models. We call large-scale alignment for chatbots, and that gave rise to a project called InspectorRAGet. And what InspectorRAGet is a way to actually aggregate community contributions to the instruction tuning of a model. So now any developer anywhere in the world can submit new skills and new knowledge to a model, and then that actually gets integrated, and then we do a weekly build of that model. So it's a different cycle of development, a different kind of community forming, where we're not just forming around a model and building inference tools and things like that, but we're actually able to merge all those contributions and then update the model every week. So we're really excited about this. It's been a fantastic partnership with Red Hat building this out. They know open source better than anyone, and we're really excited this got announced at Red Hat Summit on Tuesday by Matt Hicks, the CEO of Red Hat.
Yeah, that's awesome. And I don't know if you'd agree with this, is like, I see what IBM has done with Granite and with InspectorRAGet, and it's kind of like, I was joking with a friend the other day. I was like, it's open source putting its big boy pants on, right? Like they were kind of like moving into like open source being something that like enterprises will actually use. And I think that's really changing what we mean by open source, right? Like, I think like the big trend even a few months ago was like, oh my God, these open source models are just getting so big, right? Like they're huge parameter models. And like, isn't that the exciting thing, is that open source models will be, on par, as sophisticated as like state of the art. But what's kind of interesting here, I think, is really sort of like twofold, right? Like, I think like what's interesting with Granite is you guys are releasing a class of models of different sizes, sort of on the idea that like not everybody's going to need like the chunkiest model in the whole world, which I think is really, really interesting. And then I think, again, it's also kind of like on par with what we see out of the Apple announcement, the OpenELM announcement, right? Which is like, these are not the biggest models, but they're on-device models, right? And it kind of feels like, I don't know if you'd agree with this, David, is like, it feels like open source is finally now kind of like responding to market need. Like in some ways, like enterprises are like, how do we actually apply this stuff? And now like essentially the open source community is like trying to now, adapt to actually provide solutions to that. But I don't know if that's like a characterization you guys would agree with.
Yeah, no. And I think you're spot on. There isn't just one thing that people want to do with LLMs. So there's not going to be just one LLM that wins the day. We have our models running on laptops, and there are really interesting advantages to doing that. Like if you want to be on-prem, you don't want to be sending data over the network. It's proprietary and you're worried about IP. You can run these models in many cases on your laptop. For other applications, you want the very best performance. Say you're doing an application modernization that's just going to happen once, and it needs to be the highest quality. Then you can move to one of the larger models. So we really are trying to be responsive across the spectrum of different needs. And yeah, at IBM, we are trying to be sort of, I think you said the big boy pants, we're very transparent about what data we put in the models, which is not always true, but which is very important if you're an enterprise wanting to use these. The other point of differentiation for our models is we release them under Apache 2 license, just a clean Apache 2, no additional restrictions. And this can be really important for adoption. We knew this is something that our customers would ultimately need and want. So that's how we're evolving sort of our approach to open source. And again, yeah, like you said, meeting the customer's needs.
Yeah, definitely. And Kush, Marina, I'm not sure if you've got views on this. Is like, I think we can use this as a springboard to kind of talk about like how this is going to sort of shape the market as a whole, right? Because I think, if I'm now like an enterprise sort of thinking about how to integrate LLMs, right? It feels like there's increasingly options, right? Well, we can, we can try to do it all ourselves in-house, right? Like we can try to go with like the big proprietary models, right? And it kind of also feels like there's going to be a range of new businesses that emerge here as well. Like just like the whole business of like you come to us with a problem and we fine tune open source models for you seems like it'll increasingly become a big part of the ecosystem. But yeah, I'm kind of curious as from your point of view, kind of like in the kind of research space and even thinking about like where this all goes. Just if you've got views on how this will kind of impact the ecosystem as a whole.
Yeah, one great thing that, Instruct Lab enables is really, shifting power to value creators. So it really allows, as David said, this whole community to really congeal around this thing and make these models authentic for themselves. It's some sort of commitment to locality as well. For whatever you need for your enterprise, for your organization, you can really make things yours. So I think it's an awesome thing.
Yeah, I really appreciate being able to add the skills as you find them needed for your own use case. So the thing with all of these models is that it's very hard to predict when you put them out, what are they actually going to be used for? So being able to have the flexibility to say, oh, I've realized I have a use case, I need to adapt quickly, I need to make the model adapt quickly. Sometimes with something that's proprietary or somewhere else, you just don't have the ability to move that quickly or even to stress test or check. Is this going somewhere or is this not going to be helpful at all? So from that perspective, actually, the way that we've released Instruct Lab is very good. It's very effective for checking use cases.
It's very rare that any given company or enterprise's needs would be represented, would be a top of mind for the developer of any given base foundation model. Like does Meta, care about an insurance company. Well, they probably do, but it's not their primary
not the
concern.
main thing they're thinking about.
It's not the main thing
sitting
they're
in his
thinking
office
about.
being like, I wonder what AIG thinks about this.
Exactly. So having a base that's built for enterprise, but then giving the ability to customize and really focus and bring in knowledge and particular things you want to do that are specific to that industry can be really powerful.
So we have a few more minutes on this topic. Can I play jerk for a second, right? Because I do think that one of the most interesting things about open source is that early on, if you were a government, right, or someone worried about AI ethics or AI safety, right, you basically say, well, the rise of these few leading companies with proprietary models is like really good for us, right? Because we only have to go to a few companies and change their policies in order to sort of secure the ecosystem, right? And I think you might say, well, one of the issues of these increasing proliferation of open source models, right, and the fact that everybody's kind of going to be running their models on premises, right, is that there's a lot more room for people to misuse these models. And also, you might think that also they create all of these supply chain security issues as well. Like, I'm kind of thinking about how NPM, right? Like other instances in which open source has really taken off. Security ends up being this really big problem because the provenance of any particular component is really difficult, and your stack might rely on hundreds of open source components. And I guess I'm kind of curious. I mean, I don't think anyone's got a good solution to this. And look, I came up as a free software advocate, so I'm on the side of what's going on here. But I'd love the kind of panelists to sort of offer an opinion about that. Do you buy that those are risks? I don't know if there's kind of smart solutions you guys are thinking about. Just to kind of wrestle with that a little bit, I think is one of the most interesting parts of this development.
Yeah, well, one thing just to start off on the security issue, history has proven in open source software that open source ultimately ends up being safer, not less safe. There were efforts, for instance, to create private versions of the Linux kernel, and it turns out it's just hard to keep those safe because more eyes mean more sort of people who can find problems, understand problems, and fix them. So I think having that transparency, enabling the academic community to get involved, to build solutions for many problems that we may face, I think is super important. I will also say we're very careful about what we release. I mean, we're very careful about what data goes into these models before we release them, ensuring that they're minimizing the risks, any potential risks around potentially dangerous activities. Where we're not releasing models that we think could be used for ill intent.
Yeah, of course not. Yeah, and I think I do think that there's going to be need almost for a Consumer Reports or a Wirecutter for these models at some point, where it's basically there's going to be so many models out there that it's going to literally be well, we had a couple experts spend a few hours really testing this thing, and this is an important part of the ecosystem. Kush, it looks like you might want to get in.
Yeah, I mean, we actually do work on exactly that, the Consumer Reports sort of idea. So we call it AI fact sheets and model risk assessment. And it is exactly a way to analyze these different models that are out there, give them different scores along different dimensions. And as a consumer, you can, really look at different vendors, different sort of options, and get a good sense of what's available. So this is actually something already available through watsonx.governance, one of our flagship products.
Yeah, I imagine it's some kind of future when I quit my job as a podcast host to be a model sommelier. Yeah. It's just have you considered this model for your use case?
Yeah, fine vintage.
That's awesome.
Yeah, exactly. Fine vintage. Yeah, exactly. Right. Yeah, really good oaky overtones on this.
Yeah, 2024 was a good year for LLMs. Yeah.
Yeah, exactly. Marina, any final thoughts before we move to the next topic here?
Yeah, I would say that it's still very early days also with this technology and everything that we're going into. So especially as scientists, we would like to try not to have the hubris of thinking, yeah, we've got this, leave it with us. We've sorted out the rest of this. There's been so many interesting developments and surprises in this technology in the last few years, and we think there will continue to be for sure. In that sense, open source is actually going to be more efficient, even from a market standpoint. More eyes means more ideas, means more places that this is going to develop in unexpected and interesting ways. So it's actually even, I think, more efficient, besides whatever thoughts we may have about the morality of it as well.
Yeah, no, for sure. And again, I'm kind of arguing against myself because I'm very pro open source. I think it's just a very interesting kind of set of considerations as the whole architecture of the industry sort of shapes and changes. Well, this is great. So let's move to the second topic today. I really want to talk about retrieval augmented generation, or RAG. So if you're not familiar with this, RAG is basically one of the hotnesses in AI. If you look at the papers at iClear this year or ACL, there are a lot of papers using RAG methods. And, you know, I guess, Marina, I should keep me honest here. I mean, I think one of the reasons that it has been so prolific and of so much interest is that RAG seems to kind of open a window for solving a lot of the problems that we have with language models, right? Like, well, we can't train these models, pre-train these models all the time, but if they're really good at pulling data from elsewhere, you know, this is a good way of keeping their responses up to date. It's a good way of ensuring that they're, you know, more factual potentially. And so I'm curious because I know your group recently released a paper thinking about and using RAG. And so maybe as a springboard for the conversation, I don't know if you want to quickly talk about that, and then we can kind of more generally talk about, you know, I guess from your point of view, what you see as sort of the existing limitations of RAG and what are the big technical problems that need to be solved?
Sure, that sounds great. So the paper that you're referring to, it's a description of a methodology and a system for trying to evaluate it more deeply. Again, the point of RAG is it's one thing to be able to have a conversation with an LLM in which you ask it to write a haiku about frogs. They're great at that, no problem. We live at business use cases. And so it's very important that when you have business use cases that rely on factual information, and it's really a problem if you get things wrong, this is where you get into RAG. Like you said, being able to point to a reference of, all right, the reason I'm giving you this answer is because this is the content that I am relying on, whether it's informational or it comes from a knowledge base, whatever. Then you want to actually go and double check, is this going to act the way that I expect it to act? And it's one thing, again, to test these LLM models against large benchmarks. There were some good comments last week about benchmarks and the usefulness of them as time goes on. It's another thing to actually see what happens in a customer's use case. This is an old data analysis necessity. You have to go into, okay, what went into the test cases that you've created? You're testing. Where did your data come from? What are the documents? How have you managed to, without knowing it, introduce biases into the evaluation that you're doing? Because of the way your annotations are done, because of the way you defined your metrics, because people have different understandings of what is acceptable, what is not. You have over-corrected for a particular query type. You have over-corrected for a particular way of responding. This is all analysis that you need to do to have confidence in the solution that you put out that includes an LLM, but is not just the LLM by itself. It's the LLM as a part of a solution. And so that's something that my group does a lot. I know Kush's group does that a lot as well, is diving into the details of that, especially how we take our customers through getting confidence and what does it mean to deploy their LLM. And our system has a fun, for those of us from the 90s, we called InspectorRAGet. Yeah, InspectorRAGet. And it really is a way to make sure that you can take yourself through that analysis and feel confidence in what you're getting, not just the aggregate number.
Yeah, it's funny about the 90s. I was in a class that a friend was teaching today, or earlier this week, and one of the kids was like, I hear back in the day there's this thing called GeoCities. I hear it was really cool or something like that. I was like, oh my God, I gotta get out of here. Yeah, so there's so much to go into there, and I think there's kind of like maybe two topics we could dive into. You know, I think the first one, Marina, I'd love to get your thoughts on is I think one really great theme I think that came up from last week's episode was kind of the idea that almost AI is in this kind of weird period of like benchmark bankruptcy, where like essentially there's like all of these benchmarks that no one cares about. And then the benchmarks that people do care about are like so thoroughly gamed that they basically provide no valid information anymore. And like one outcome that I think Shobit was saying on the episode was like, well, that's one of the reasons why like the solution now is like just talk to the model for 15 minutes and then you figure out whether or not it's good or not. And it strikes me that like, I don't know if you put InspectorRAGet in kind of this context. It's like, it seems like there's also a switch from benchmarks to like monitoring as the way that we really assess whether or not models are high quality. I don't know if you'd buy that, because as I take kind of your group's work is an attempt to say, okay, well, we're not going to really, benchmarks are a useful guide, but really in practice, what most people want is to see like lots and lots of telemetry about their models. And like, that's how we approach this problem. But kind of curious to get your response on that. Like, do you buy the idea that AI is in a benchmark bankruptcy? And do you see kind of RAGet as sort of a solution to that or an answer to that in some ways?
Yeah, I think you should think of benchmarks as something that you should iterate on rapidly and evolve. Now, the problem with talk to the model for 15 minutes and just get it vibes kind of the feel of it is people are not very good at coming up with what is the right thing to talk about it to for 15 minutes. Consistently, they are not very good. They themselves will only think of whatever came into their head, whatever they were talking about to their customer last week, and they will introduce, like I said, a lot of biases in what they thought of. Then you end up being very nastily surprised when you actually go ahead and deploy your model, and they're like, well, that didn't work, but I talked to it for 15 minutes. It seemed fine. You wouldn't also, deploy a representative to a customer after talking to them for 15 minutes and thinking, that seems fine. So realistically, what you actually want, and what I hope the point is of approaches like InspectorRAGet, is constant evolving benchmarks. Yeah, talk to it for 15 minutes and then go check yourself. Hey, what data did you end up actually putting in? What kind of questions did you end up putting in? Do you realize that you didn't do the right vibe check? Do that a few times, your vibe check becomes then into something systematic. But it's something that is iterative, that is interactive, rather than some academic somewhere put out a benchmark. I don't know what this has to do with my data. Make your own, make it iterative, and constantly, check yourself for what you're doing is actually proper quality. That ends up being really the right thing to do. So move yourself from that, shout out to Daniel Kahneman, from that system one thinking to the system two thinking. Then you're going to have confidence in what you're actually deploying.
Yeah, this is I think it's so interesting because I think this is what you're describing is going to be an enormous need across like every company that attempts to adopt this stuff. And I was joking earlier about being a model sommelier. Like, I think my other business proposal is like, you're an eval atelier, where you're basically like, we help to craft finely crafted evals for like what you need. And it kind of what you're talking about, because like the art of creating a good benchmark and evolving that benchmark. I think
you're describing a lot of our jobs actually here at IBM that's like, literally what we're doing for our customers.
Eval atelier.
Yeah.
So, David, Kush, I don't know if you got responses you want to jump in.
Maybe I can be a little bit controversial. People talk about RAG being a solution for hallucination, for lack of factuality, lack of faithfulness, lack of groundedness, these sort of things. But to me, it's part of the solution, but I don't think it's the full solution, because even when you get the retrieved documents, there's a model in between, and it can ignore those documents, it can get confused by them, it can, just hallucinate anyways, all sorts of things. So to me, what Marina is talking about is very important, not just, over time, but as part of the process initially as well, or in runtime, in inference time. So, checking for hallucinations separately, thinking about, can we trace back the information? Where did it come from in those documents? Can we even come up with new architectures that don't hallucinate by design in some ways? So I think RAG gets a lot of play right now, but I think it's a stepping stone. I don't think it's the end of the journey.
I actually completely agree with you. Fully agree with you. RAG has not fixed it. It's just an additional step in the direction. I completely agree with you.
Interesting. So do you think in I don't know, it's always tough to predict on these things. Like in 2 years, we'll be talking about RAG?
I think we will, because RAG is it's search, right? And a lot of the companies who are in the LLM game are search companies at the end of the day. So I think it'll stick around. It'll have a lot to do. But I think for enterprise use cases, maybe it'll get a little bit less emphasis, maybe not. I don't know.
Well, for freshness of data, some kind of retrieval can be helpful. Like you just added it to the database, you can retrieve it immediately. So there are more than one problem that RAG solves, and I agree with Kush and Marina that hallucination it helps a little bit. Like it's a separate problem that we need to address lots of different ways. But the ability to access new information, the ability to customize quickly. We're starting to get, I think, layers of technology that allow us to address that. InstructLab's one of them. If you wanted to ingest knowledge into the LLM and build it into into the LLM itself, you can do that. But you probably still want to be retrieving things, and there's going to be a balance, and we're going to figure that balance out, I think, over the next couple of years.
Yeah, I think it's definitely like the much more realistic pathway that I've heard, right? Like, because I think like the other alternatives I've heard are like, well, at some point the model will become so big and know everything, and then we'll be able to pre-train it frequently enough. And I'm just like, how many H100s are you going to buy to pull this off? It just like is not within the realm of possibility. So
and it's not a new concept. Go ahead, David. Sorry.
No, I was just going to say, and not every company is going to give their data over to OpenAI
Sure.
to let them, their proprietary data. It's a real problem.
Yeah, and all I was going to say is, like these sort of ideas, like having multiple levels and layers, it's part of computer engineering. Caching, like different types of locality. This is all like very much the sort of thinking that computer people have had. So it just needs to come into this too.
Yeah, orchestration, right? And making sure that there's routing involved, there's decisions involved, there's different checks, there's different guards. That's not going to go away. I don't care how long you've trained the LLM. That's not going to be fixed.
Yeah, for sure. So we have a few minutes left on this topic. I think the last area that I want to kind of push us into is, I think, Marina, you had kind of a really sort of interesting comment when you're explaining InspectorRAGet, which is basically this kind of feature of trust, right? Essentially, like, what does a user need to be shown to trust the model? And I think what I love about that topic is that in some ways it's pushes you into the realm away from like it turns out people trust models regardless whether or not they're a huge parameter model or a tiny model. And I heard this great anecdote where this MLE was telling me this story where they're like, we were doing an eval where there's these side-by-sides. And what we discovered is that the users that we were testing against just felt that longer outputs were more credible and trustworthy, regardless of any content they included, right? And I was like, oh, that makes sense because like you're saying, like, do 500 of these tasks in the next hour. And so they're just using these visual heuristics to evaluate text. And one visual heuristic that we use to tell whether or not something is more substantive is like, is it long and look dense? And I think this is like such an interesting thing because if you go down that route, I guess it's a prescription for madness because you're basically like, well, does font choice influence how people think, like how trustworthy their models are? Yeah, exactly. And so I guess, Marina, I'd love for you to kind of like riff on that a little bit is like, how far does this rabbit hole go? Like once you move away from benchmarks and you say, we're going to give you a dashboard of different things, you're now kind of in almost like the theater of trust. Like, what do we need to show you? And what is the metric that drives the most trust with the user? And is that trust justified or not? And just would love to get your thoughts on that as someone who's working in the space.
There's some real interesting psychology here. So we know that people get extremely mad at computers when they make one mistake, but they're much more okay if you were told that it was a human. So that's an interesting psychology.
Yeah.
There's another fact that these models are fabulous snake oil salesmen. They will tell you something that you will read it and you'll believe it, even if in the back of your mind you're like, wait, isn't that not what I thought that was? But it'll sound so convincing and so accurate that you're like, oh yeah, that's the right answer. I have no further questions. They're very good at that. So in that sense, actually, even human evaluation is very challenging. People are bad at catching these kinds of things. On the other hand, you find yourself in an enterprise situation and that's risky. If you really did give incorrect information, that is very risky. It's a good reason that you can't really deploy these models by themselves with no support. But I think there's a lot of psychology actually in setting expectation, just in the same way that when we first had Wikipedia in the world, when we first had Google search, and people thought, oh, well, if it's on the internet, it's true. And then people learned. And I think that over time, it's going to be the same thing where you're going to learn what kind of things really need to be. What is the right way to interact with these models? What is the safe way? What is the consumer report sort of appropriate way? So some of this is technology. A lot of this is people. A lot of this is people psychology. I cannot give you enough data points and tell you I will never, ever, ever make a mistake in this model. It's not possible. So we're going to have to figure out how it is to set people's expectations. If people are allowed to sometimes make mistakes and you ask for a clarification, how do we get to that state of the world also with the use of the LLM technology?
Yeah, for sure. Yeah, I think, and this sort of pushes into, I think, a sort of interesting direction is like under certain conditions, I'll just throw out the hot take is like under certain conditions, basically optimally safe performance of the model is not necessarily optimally easy to use, I guess, right? So like that is to say like a perfectly articulate model may actually signal more trustworthiness than is warranted. And so there actually may be weird situations where there's kind of this trade-off, which is like we actually want it to perform worse because it inspires an optimal level of doubt in the user, right? Would be sort of the theory that I guess I'm arguing.
Well, short of you don't have to have a performer, if it could just express its own uncertainty, that would already be a big improvement because people really aren't great at dissociating things like fluency and convincingness of sort of discourse with actual truth, and particularly in contexts that enterprises are working in with RAG, where you're taking enterprise documents, HR documents, and policies, and you have to be correct about them unless the person who's vibe checking that model really understands those policies in perfect detail. It's very tricky to evaluate, and people tend to be fooled very easily.
Chris, you want to jump in? I see you kind of.
No, I mean, I think the word Marina used earlier, humility, is the key. I mean, the AI needs to be humble, and we need to be humble as well. So I think that combination is the right way to go.
Yeah, for sure. Yeah, and I think it's part of the problem too. I was talking with my friend who kind of relayed this story as well, is basically that people have all these expectations that are built up around computers, which makes this particularly difficult. And like the language model behaves in such a fundamentally different way that it's like violating our expectations, where you're like, it's good at poetry, but bad at math. Like that literally flips everything we have built up in terms of intuitions about computers for like the last 20 years. And so like the adage I've been using is like everything you think computers are good at, like LLMs are bad at. Everything that LLMs are bad at, like, computers are good at. And there's kind of this weird mismatch that we're sort of navigating at the moment. All right, so Kush, you and I are going to kick this topic off. This is going to be the big challenge of the episode, which is if you've been watching the more nerdy channels of the AI discourse online, people have been very recently excited by something called the Kolmogorov-Arnold representation theorem, which is giving rise to a paper that proposes a kind of Kolmogorov-Arnold network, or CAN for short.
Yep.
And it's very difficult to tell from the outside, I think, if you're not a technical person, as to like what it is and why it's exciting, which worries me because it has all of the indications of being like, oh, do you use blockchain? Because like blockchain will solve this, right? Like I think you're like going to rapidly go down that direction. So what I kind of want to do over the next few minutes as we close out this episode is to basically give the clearest, easiest to understand explanation of CANs that anyone has yet articulated on the internet. And we're going to do this together, right?
Okay.
So Kush, no pressure on this
one. No pressure.
So I think, Kush, maybe the best place to start reading some of the papers is, can you give kind of like a quick explanation of why models, large language models, approximate functions? What does that mean exactly?
Yeah, that's precisely the right place to start. So, I mean, so a mathematical function, it's looking in some space, right? So in middle school or high school, we saw these one-dimensional functions. If our data was just one-dimensional, what that function is trying to do is fit that data, and by that, use the function rather than the data to predict the next thing. So by doing so, we're actually able to so-called generalize. So data tells us the pattern, the function describes the pattern, so that the next time we want to make a prediction, we use the function instead of the past data. So I think that's a very key point, and then we can go into what those functions are, how to represent those functions, and how to compute those functions. But yeah, that's the starting point.
Right. And a prediction here, just to make it very simple, is like tall people, that's one variable, tend to be heavier. Is that right? Like, for example, that's a prediction that you could build a function around.
Yeah, exactly. And you can be very quantitative about that. So if I'm 6 feet tall, maybe that predicts that I'm 180 pounds or something like that. Yeah. So, yeah.
So then I think the next step, we're going to take this step by step. We're going to think through this problem step by step, right? Is basically, so as I take it, right, like one of the things that machine learning has really done better than kind of traditional models of AI or traditional models of, computer programming is that we've frequently tried to kind of like hand draft all of these rules, right? So like you want to write an algorithm to divide, pictures of cats from pictures of dogs, you would do feature engineering, right? You get a bunch of people together to kind of like write these equations, these functions out, right? And I guess, is it right to say that machine learning, what it's been really good at doing is like coming up with these functions on its own, right? Like to basically come up with those rules on its own to do this prediction.
Yeah, I think that's a good way to put it. I'll be a little bit more specific, though. So
Sure, yeah.
we as humans, the algorithm designers, etc., have been the ones who come up with what the functions are. The functions have parameters, and it's the learning algorithm that's figuring out the parameters to best fit the data. But at some level, we, the computer scientists, the AI folks, are the ones who decided what were the functions in this library or this universe of possible functions, and then let the algorithm figure out the nuance, the parameters, and so forth.
Yeah, for sure. And so what we do here, I guess, right now in the world of AI is multi-layer perceptrons, right? Which is like this very particular way of implementing AI that is doing the approximation of these complex functions on its own and can solve all of these magical things, right? Like it can, have conversations with you, it can sort pictures of cats from dogs, whatever you want.
Yep.
You talk a little bit about maybe like the trade-offs of that. Like what do we need to do in order to achieve that magic, right?
Yeah.
Like, yeah.
Yeah, so there used to be this car dealership that had a commercial one in the 90s again. So they used to
We're really
about,
dating all of ourselves here on this
exactly.
episode. So I'm really enjoying this.
Yeah, so they used to say stacking them deep, selling them cheap in terms of their cars. So with these, the multi-layer perceptrons or the feed-forward neural networks, the trend has been just, there's this one kind of these layers. What they do is they multiply some inputs by some weights, add them up, and then apply a nonlinearity, something often which is called a ReLU function, a rectified linear unit, which kind of changes the output, right? So you have those, you layer them on top of each other, you stack them really deep, you keep doing this, and that way, you actually end up with the ability to end up with almost any sort of nonlinear function to describe the data. So you talked about this universal representation or approximation theorems and stuff. So you can actually prove that through even not very deep neural networks, you're able to represent any function that you have in front of you.
Yeah. So that seems like we're at the magic, right? Like this is how it works. I guess one result of that, right, is that these models have been like, they're really expensive to make. Like you need like a lot of energy and a lot of chips and a lot of data and a lot of computing time. And so along comes Kolmogorov and Arnold. I actually don't know who those people are. I just know them from their representation theorem.
You should know Kolmogorov from a lot of other things.
Yeah. He's that one. Okay,
yeah,
all right.
Same guy.
The
big
same
boy
Kolmogorov.
Okay, all right. Yeah. I know that guy. It's the Big Lebowski. So tell me about the representation theorem, right? What does it? What does it tell us? What's the big deal?
Yeah, so like we just were talking about, so when you have some function that you're trying to represent, mathematicians have come up with all sorts of ways to be able to decompose that goal of representing this function I have in front of me in terms of more primitive other functions, right? So this is, we see it as an electrical engineer, I see it like Fourier transforms or Fourier series are ways of decomposing a function into sines and cosine functions. The same way with the multi-layer perceptrons, it's into that particular structure. You're decomposing into these weights and these nonlinearities. So what the Kolmogorov-Arnold representation theorem is about is decomposing, again, any function into some other functions. In this case, they happen to be one-dimensional. So they could be splines or some other smooth one-dimensional function. And by combining them in a particular summation, you can, again, represent any multidimensional nonlinear function. And that's the proof, is what Kolmogorov-Arnold tells us, that in this way of taking 1D functions, you can come up and represent any multidimensional function.
Yeah, which is pretty wild, right? Because what you're sort of telling me is basically that like the machine learning models that we have now can work this magic, right? They basically come up with a magic mathematical formula that can help you tell pictures of cats from dogs. Let's just take that example. And then kind of what you're saying is that we can take that magic formula and like represent it, like we can break it down to these tiny, tiny, tiny Lego blocks, right? Like all the way down to what we were just talking about, like tall people are heavier, like single variable stuff, right? And kind of the theory, and Kush, you keep me honest, you're the one who actually understands this stuff, is like like any, I don't know, or like most very complex formulas can be reducible in this way, I think is what the theorem is saying. Is that right?
Exactly.
Okay, so we're there. The CAN network then is a network that attempts to do that?
Yeah, exactly. So so when in the regular neural network, we had these weights on these edges that are multiplying the inputs. Here, we're applying that function, the splines, or the other sort of 1D sort of nonlinear function. And then instead of, you add in the same way. So the CAN is also adding up the inputs, but then there's no additional nonlinearity afterwards, like the ReLU that we see in the normal neural network. So all the nonlinearity is done before you add things up. So it's just more complication in one place rather than in a different place. And so just by doing that change, you can reduce the number of parameters because this more complicated thing on the edges is actually more able to represent these weird or various sort of behaviors. So that's kind of what it's trying to do.
Nice. So we're there. Deep breath.
Yes.
2 last questions.
Yes.
Does it matter? What would CAN models? What's the promise of CAN models if that you can do this? It seems like you've just taken this complex thing and turned it into a bunch of Lego blocks.
Yeah.
So from my one brain cell standpoint, I'm like, isn't that kind of the same thing?
Yeah. So it's true. I mean, you're just shifting the nonlinearities from one place to a different place. One thing that the CANs are able to do better a little bit is more interpretability. So when you look at those splines, they actually make sense to us. So that height and weight sort of relationship or any of those other things, we can understand better. So there's this interpretability method called SHAP, which people have been using for a while. This is like automatic SHAP without having to do SHAP in a sense.
And interpretability there for some folks who are not maybe as into the papers is just simply understanding what the models, why the model is doing what it's doing.
Yeah, exactly. Exactly. Yep. And so, I mean, that's one advantage. The disadvantage, though, is that our hardware infrastructure has not been optimized for these sort of things, for these splines and so forth, whereas the matrix vector computations for neural networks are kind of like very highly optimized through those H100s and so forth. So that's, I think, the difference. We might, if this catches on, I mean, develop some hardware for this type of thing as well. And I mean, the last point that I'll make is these are not new ideas. I mean, this is something that's been around. Even our team, like a couple of years ago, we developed something called coffer nets. It uses continued fractions, which are a third way of representing functions. Also, it has a approximation or universal approximation theorem associated with it. It uses continued fractions that have been known since antiquity, like the ancient Indians and ancient Greeks knew about all this stuff. So, I mean, like all this fancy math is great, and it's just different ways of putting together, I mean, different of these functions together. And then at the end of the day, they all let you, I mean, kind of represent these different nonlinear functions. How you train them might be more or less costly, where the interpretability is might be more or less easy to or hard. So I mean, it could turn into something. It might just be another option. So we'll see.
Yeah, for sure. Yeah, it's fascinating. And that, I think, opens up definitely a direction that I hadn't really thought of, because I think the main thing I had heard is, well, you can make much more energy efficient models, right? But it seems like 2 things you're pointing out. One of them is like, we might be able to understand why these models are making the decisions they do at a much like closer level of depth than we have in the past, which seems huge. And then I think the second point is actually that this is like not new stuff, right? Like, I mean, much like neural nets themselves, right? This is like, we're just like pulling all this old stuff back again and being like, oh, I guess it works now, you know, ultimately.
Well, and I think that resonates really well with Kush's point about the hardware match. I mean, oftentimes, you know, we get success in the field moves not because something is the mathematically optimal thing, but it's something that can be done at sort of irrational scale with irrational speed. And as you say, deep learning was, kind of a rebrand of artificial neural networks. It was around for decades before it caught on. Why did it catch on? It's not because there were some mathematical breakthroughs, because the hardware, like GPUs by accident, were really good at doing this. And then that just sort of set us on a path. So Obviously, all these new developments are really exciting, and we could build different hardware potentially. But any new idea like this is going to compete against how wonderfully good GPUs are at doing the basic computations needed for deep learning. So it's an interesting battle, an interesting set of trade-offs there.
Yeah, that I think relationship between sort of like hardware and what's happening on the model side, I think is like one of the most interesting aspects of this. And like, how long does it take for a model to influence hardware? Are we just locked into CUDA for the rest of our lives? It's like all these things are like very, very interesting questions. So Marina, any last thoughts before we close up today?
Yeah, even more general comment continuing what Kush and David said is representations of data are not created equal. So yes, it's the same information, but when you change the way that you represent it, you're able to do things with it that you weren't able to before. So even with something like a large language model, you're representing data that exists, let's say on the internet, but you're representing it in such a way that you can access it in a way that you couldn't before. Same thing with, for example, CAN versus MLP. The representation changes, there's going to be trade-offs, but it's always very interesting to try this. The fact that we now have more of these options open to us because the hardware has caught up to the math that has been around for years or decades or centuries. Yeah, that means try again, see what new things will come up. Data representation is really one of the things underlying driving this current era of AI. So more work in this direction is just going to continue to drive things in an interesting place.
That's great. Yeah. Well, I can't think of a better note to end on. Kush, MVP, thank you for coming on the show again. And Marina, David, hope to have you on the show again. And I hope all of you listeners out there join us next week for another episode of Mixture of Experts. Thanks, everyone.
Thanks.
Thank you.
Appreciate it.